Oh. Gotta go. Oh. Hey. Oh. Everything is wrong here. Everything. There must be a way to extract an int literal from a variable, right? Alive? See, I don't feel like I'm live. Oh, I am live. I'm absolutely live. There we go. Oh. Just new version of Java. Well, damn. Why you tell me soon?
Hey everyone. I just closed that, didn't I? I didn't mean to. I've got to do this. We've booted. I've had it on screen. I didn't do this before. It's all my fault. It's all my fault. Ah, yeah. Insert. This is creating a arrays lol. It's downloaded. It's ready installed. Tell me later. Tell me later. What are we doing? I haven't even booted up my book. Hey, anyone watching from like any time before the 2000s? Your books have batteries, and you have to charge them up. Your books can also sometimes access the internet and spy on. What? Hey, it's the C++ primer, guys. Welcome, willkommen, bienvenue, yokoso. I don't know why we're doing all the welcome things. We're on part 15 already. Quote unquote part 15. Not that that means anything here. This isn't a sequential kind of thing. It's a book where we are working from the C++ primer book, version 5, where we learn C++ and its many facets. Multi-dimensional arrays, that's why I stopped. I understand everything now. Yes. Oh, hello. Hello. Multi-line, single-line comments can be collapsed together. Interesting. What? No. So let's read what it has to say about multidimensional arrays. It says here that a multidimensional array does not exist. And what we refer to in C++ as a multidimensional array is actually simply an array of arrays, which is, in fact, actually, if you think about it, a multidimensional array, because strictly speaking, I guess the multidimensional refers to axes. We usually look at arrays. I don't have any of the code up. I can't just whip it out and show you. But we tend to think of arrays as shape, right? You have your array, and you have, you know, whatever, and it has a sequence of items within the array. One-dimensional. It's a line, right? And then if each of those array items is itself an array of items, you have a two-dimensional array, because you have an array going left to right, incrementing array 1, array 2, array 3, array 4, array 5, and then those increments themselves have figures within them, mixed like a square shape. And then, you know, you can have arrays of arrays of arrays. You go to three-dimensional, you got a cube of array data points that you can do, and that's cool. That's what we mean. It breaks down mentally, conceptually, for some people, I guess, when you go above 3, because most people. Thank you, Starlings. Please, hey. Oh my God. Sorry, because most people live in the world, and they have basically 3 axes of movement. They have a physicality in 3 dimensions. The 4th dimension that we like to work with is time. Time is not relevant for C or C++ because a lot of this stuff is not dynamic. Ergo, when you hit a 4th dimension multi-dimensional array, quote unquote, it's hard to conceptualize, really hard to visualize for a person, because you're dealing with you know, quote unquote shapes which are quote unquote invisible, unperceivable by the human people. We have eyes, and we perceive a 3D world as essentially a kind of a bunch of 2D images. It's, you know, it's stereoscopic 3D, but it's just you've got 2 cameras, okay, buddy? They don't trace 3D graph lines, okay? Anyway, if you want to see, and I say see tentatively, if you want to see 3D or 2D or visualization or representations of higher order multi-dimensional arrays, 3 Blue 1 Brown has some good videos. He's got a video on visualizing multi-dimensional arrays, which was basically just kind of like a fun thing for him to do to kind of give you an idea of what a multi-dimensional array could look like. And it plots the points, the extremes, based on summing to 1 or something. I can't remember. Really, it's been a long time since I watched that video. And you get some weird shapes. You know, he starts off simple with a plane, and then a cube, or it was a sphere, wasn't it? Wasn't a cube. It was a sphere. Was it a circle? In fact, not a plane. Anyway, But then, you know, I think the fourth or the fifth dimensional array turned out it looked like the AT&T globe logo. You know, the globe that's made out of like little globe segments. It's really weird. Check that video out. 3 Blue 1 Brown. He's got that video. He's also got a video on quaternions, which I think is a related branch. So you can have a look at that as well. I haven't linked them here because I haven't loaded them, haven't watched them in over a year myself. You know, you watch a video once and then you kind of know everything in the video, but you can't recall it to memory, and you don't want to watch it again. It's weird. You know, like watching a film. You think you know it, you know it, so you don't want to watch it again because you know all the stuff, and then you eventually get cajoled into watching the film again. And you find stuff you didn't know, stuff you didn't see. Maybe I should go back and watch those videos. Good videos. Anyway, we can define an array whose elements are arrays by providing two dimensions: the dimension of the array itself and the dimension of its elements. Okay. So if we have int ia34, hold on, I'll write this down. This is example code. So this equates to this equates to, please indent. This equates to what are you doing with your tabs? Where are your tabs? Will you stop trying to guess what I'm trying to type every time Visual Studio? This relates to this. So you've got your 3 arrays here, and then each of those 3 arrays has got 4 elements in it. Okay? We all good about that? Oh no. And then we have so this is 10 arrays, right? Yeah. This is an array of 10 arrays, which are 20 units long each, and each of those 20 units is an array of 30 units. They're all ints initialized to 0. So we can think of this as being, you know, 10 spaces across, 20 spaces deep, and then going back or forward, depending on which way you want to extrude, 30 places on all of those things, all initialized to 0. So I'm just trying to think if there's an easy way of doing a 3D of that, and there isn't a fun, easy way that I can do that right now. Not that I know of. I mean, there is, obviously. But I'm not a 3D guy, I'm sorry. I'm a 2D guy. Not like that. I have no 3D brain, is what I'm trying to say. Like, I don't like Blender. No, I like Blender. Blender's great, but I've never gotten on with the 3D modeling aspect of Blender, which is ironically like the 99% of the program. I use it for video editing. Hey, come at me, bro. But I really like Fusion 360. That's a good 3D modeling program. However, it doesn't optimize for 3D models. Optimizes for like machining. So most of the geometry ends up as like extrapolated kind of vectors, as it were. It's not built on tries. It's visualized as tries, but it's basically a whole bunch of 2D sketches that are scaffolded together with 3D kind of drapes. And the visualization works really fast, which is kind of weird. But I guess, you're only visualizing like one or two things in the scene. It's like, yeah, trade-offs, I guess. So we can more easily understand these definitions by reading them from the inside out. But yeah, I like to think of multi-dimensional arrays, what little I have done of them, as like addresses. So, or like a series of sequential boxes or something like that, I don't know. So you have your main array, and you have 1 through 10, and then you have each one of those has 1 through 20, or 0 through 19, I guess. And then each one of those has got its values within. So if you think of it like a box, you've got 10 boxes, and each one of those boxes has got 20 boxes in it. So you can access the data in any one of those 200 boxes by typing in the numbers there. You just use the key value. And it's important to understand that I tell you, and that I reiterate to myself, that while we are specifying the size of the arrays here, array indices are 0, what do you call it? Come on. Line. God damn it. They start at 0. So everything is 1 less. So the 30th item in the 20th box in the 10th line of the array is 9, 19, 29. Which is good to know, right? Right. What's that noise? Oh, it's the starlings again. God damn it! It's the starlings. I don't know if you can hear them. I can hear them. Hold on. Yeah, it doesn't look like you can hear them. Alright, okay. I'll stop messing around now. Oh, there are no limit on how many subscripts are used. In a two-dimensional array, the first dimension is usually referred to as the row, and the second dimension is usually referred to as the column, as a metaphor, a mental metaphor for visualizing, understanding, remembering, and accessing the information in the array, and it is a useful tool in two-dimensional arrays. Yes, three-dimensional arrays maybe if you've got the brain for the 3D geometry. Fourth and higher dimensional arrays starting to lose its importance in a visualization context. You've just got to kind of, yeah. Anyway, initializing the elements of a multidimensional array. As with any array, you can initialize the elements by providing a bracketed list of initializers. Multidimensional arrays may be initialized by specifying bracketed values of each row. All right, okay. Equivalent initialization without the optional nested brackets for each row. Okay. So you can just go, right? You can just hammer in values and they will put them into the arrays from 0 up. That's nice. But if you use nested arrays, you can specify, if you use nested initialization, sorry, you can specify which row, column, position to put things into. It's helpful. We can use a subscript to access the information. Very good. The hell? All right, okay. So if you specify all of the subscripts, you get the value at that point in your multidimensional array. If you do not specify all the subscripts, you get everything at that point. So if you have a 4-dimensional array, or let's use int r actually. So if you type in int r 0 0 in square brackets, 2 square brackets 0 0, you'd get your first array of 30 0 initialized ints. Very good. That's cool. I like that. I don't know if it'd be helpful, but it'd be good for if you got if you got a sequence of numbers that you want to retrieve and they're there, and you get them, you do that. Huh. Oh, hang on, what's going on here? So, if a row is a reference to an array of 4 ints, find that reference in the second row. Oh, yeah. Okay, yeah. Another example, it is common to use a pair of nested for loops to process the elements in a multidimensional array. Yeah, so multidimensional arrays, and this is struck into my mind with an adamantium chisel. Multidimensional arrays are how bitmaps store pixel information. Or at least, no, it's how it's, no, what? I've lost my train of thought. No, it's, it was a, yeah, I mean, it is. Each pixel is itself an array of 3 ints, right? And then you have your width and your height, and then a small header area. When you load them into, when you load a bitmap into C, you can use the first and the second subscripts to navigate individual pixels, and you can use that to manipulate. I failed to completely grasp this when I was doing the CS50. Big shame. It's where I stopped because I kind of, I couldn't do it. I lost interest, and then one day I was at work and I had, eureka moment. That's how you do it. And then I never went back to it. It was like, oh, I've got it. Whatever. It was like a year later. I don't even know why it was that hard. Like, I think it was just because I was put off by doing like exact bit calculations. But that's what you got to do. I mean, you're provided with the width and the height for a bitmap anyway. But anyway, besides the point. Moving on. So here we go. Constant expression size t, row count equals 3, call count equals 4. In IA, row count, call count. 12 uninitialized elements for each row. 4 size t, I equals 0. I does not equal row count plus I. For size t, j equals 0, j does not equal call count plus j. Is it not j plus I plus plus? Back when I was doing C, we used no, because we used the increment. We used the increment in the function. Like, yeah. Sometimes. Doesn't plus I increment it and then do it? Gonna have to look that up later. Remind me to look that up later. The outer for loops through each array elements in IA, inner for loops through elements in those interior arrays. In this case, set the value for each array and the index, blah blah blah. Easy peasy. Use standard, we can simplify the previous loop by using a range for size tcnt equals 0 for auto and row, IA for auto and call row, for every element in IA, for every element in row, call equals cnt plus cnt. Okay. So to use an iterator, a C++ iterator over a multi-dimensional array, you got to use references to the variables you're using to iterate over the thing, rather than ints, because if you leave them as ints, there'll be a pointer conversion, and then the internal loop will break and it will not compile. Cool. I'll keep that in mind. Pointers and multi-dimensional arrays. With an array, you can use the name of a multi-dimensional array. Automatically converted to a pointer to the first element in the array. Multi-dimensional arrays, arrays. The pointer type to which an array converts is a pointer to the first inner array. Wait, what? So you can have a pointer to an array of the stuff. Okay. You need a parenthesis around the variable name and the pointer declaration to make sure that it points to an array and is not an array of pointers. Okay. See, normally I'd be down with using auto instead of int, but oh, the bitrate seems to be tanking. We seem to be losing frame. Uh-oh. I guess I'll just wrap up this section real quick, and we'll be done. Here we go. What have we got? For loop. Okay, we got the auto p. We got double loops, nested loops. Library determine the end pointer. We use auto to avoid having to write the type returned from begin. Alright, okay. Type alias can make it easier to read, write, and understand pointers to multi-dimensional arrays. For example, using int array equals int 4. Type def int array 4. We start by defining int array as a name for the type array of 4 ints. We use that type to define our loop control variable for the outer for loop, but that's only going to work for specific sizes of things. Write 3 different versions of a program to print the elements of IA. One version should use range 4 to manage the iteration. The other 2 should use ordinary for loop, with one case using subscripts and the others using pointers. All 3 programs write the types directly, that is, do not use type alias, auto, or decal type to simplify the code. This is like I don't know what I'm doing. See out. This always confuses me. The see out is gonna be I've got some, here we go, reference of type int and non-const qualifier cannot be initialized with the value of type int 4. Oh. It's not meant to be int 3. What? This range-based for statement requires a suitable begin function and none was found. I have skipped too much. Oh. Star cannot be usually initialized an entity type of const int n. Array of reference is not allowed. But what are you? So that's fine. Just give it a quick old Is that right? Do you need commas in there? Is that right? We've got an error here. Special must be a modifiable L value. Too many initialize values. Too many initialize. Weird. So if we do that, okay. Uh, I does not equal three. Oh, what am I doing here? J is less than 4. It does not equal. Psh. They're not commas, they're semicolons. They're not semicolons? Okay. Too many semicolons. Can I just put one of those in there? No, I cannot. It wants to see out, right? There we go. So you go 1, 2, 3, 4, 5, 6, 7, 8, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we've done half of exercise 1, half of exercise 3. Where are my exercises gone? And then we've got our final, definitely not just copying out the textbook one. Now that int equals begin IA. What do you mean no? Identify begin is undefined. Did I spell it wrong? No? Have I used it before? Pretty sure I used it. What the hell has gone on here? Cool. Can just delete whole blocks of code. I have not used it. for I throw in an auto, it's still like potential fixes. Alt and enter or control. Change begin to standard basic string view begin. Using namespace. Change begin to standard begin. Yeah. Oh right, I haven't added it to the. Do I not have using namespace standard? Okay. Value of type int star 4 cannot be used to initialize an entity of type int. Do you remember when I said the parentheses are required to make sure we're initializing a pointer to an array of 4 items and not an array of 4 pointers? Big brain plays. Huge brain plays. Here's begin IA. P does not equal end. Oh, I made a boo-boo. Do you mean it's expected a semicolon? We've lost a bracket. Wow, okay. you. Okay, so huge brain play. I told myself not to do this, and then I did it. So the type of begin IA is. Oh, yeah, it is a 4. So it's a pointer to an array of 4 ints. So you need to make a pointer with the parentheses around the pointer to an array of 4. That's why I was messing up on this. This is why this is this. But we've done it. We've got our example code, good and squeaky, and between these 3, I think I've covered enough of the exercise to pass through that. Been going for almost an hour now. I'm not really tired, but I do have some constraints. I gotta go. It was fun learning about my multi-dimensional arrays, and that is the end of the chapter, in fact. So I will leave the chapter summary for next week so I don't forget everything. Or rather, when I have forgotten everything, I can remember it again by going through the chapter summary. I will charge my book, and I will sign off this video. So thank you very much for tuning into the live video. If you tune into the live video, thank you very much for watching the video on demand, whether that be a Twitch VOD or a YouTube VOD. And as always, I will see you in the next episode.